Okay, so let's just jump right in. What if? What if the universe isn't really a collection of things floating around in space,
Uh-huh.
but instead it's fundamentally like a symphony of motion?
A symphony of motion.
And
Okay, I like that framing.
seriously, just let that idea sit for a second, because that's the core, the really fascinating heart of what we're plunging into today, motion theory.
Right, this alternative perspective.
Yeah, and we've got some seriously thought-provoking material here. It basically suggests that everything we perceive, a speck of dust, a galaxy, even time ticking,
All of it.
isn't made of static stuff. It's actually intricate rhythmic loops of motion.
So not just movement like velocity, but organized patterns.
Exactly. Organized, repeating patterns as the very, essence of reality. And the source we're looking at puts it pretty powerfully. It says, once you hear this idea, you might just see the cosmos in a completely new light.
That's a bold claim.
It is. So let's dive deep. Let's try and unpack this potentially revolutionary perspective on physics.
Okay, let's do it. So motion theory, at its heart, it really does flip the script on, how we usually understand the universe.
This is the script.
Instead of thinking about fundamental particles interacting through forces, the standard way.
Right, like little billiard balls and springs, almost.
Kind of.
Yeah.
It proposes that everything is these structured motion loops. You have to imagine these incredibly complex, repeating dances of movement.
Okay, dances of movement.
And from that single idea, that central premise, it then reinterprets some of our most basic concepts. Mass, for instance.
Okay, mass. How does that work?
Well, it's not seen as an inherent amount of stuff. It's more about the way that motion resists being pushed around, resists redistribution.
So less like a solid brick.
And more like the inertia of, say, a spinning top, how it resists being tilted. That kind of resistance.
Interesting. Okay, what about gravity? That's a big one.
Huge. So gravity isn't presented as a force pulling things or even Einstein's bending of space-time.
Which is pretty abstract anyway.
Exactly. It's seen more as motion naturally flowing, converging towards areas where these rhythmic loops are more densely synchronized. Sync density, they call it.
Sync density. Okay, so things fall towards denser rhythm.
Sort of, yeah. And time. Not a universal clock ticking everywhere at the same rate.
No.
It's more of a local measure. It relates to how precisely you can resolve or distinguish these rhythms locally.
Wow. Okay. And light. You mentioned light too.
Right. Light's another big one.
Yeah.
Traditionally, we think wave or particle, right?
Duality.
Yeah, the classic physics puzzle.
Motion theory says, nope. It's structured rhythmic motion that collapses and then reforms in a new state of synchronization.
Collapses and reforms.
Yeah.
So we're not catching photons.
That's the idea.
Yeah.
And what's really fascinating, or maybe telling, is how it deliberately avoids what the source calls magic particles and invisible forces.
Right. No need for hidden messengers or fields that just are.
It tries to explain things based purely on the motion itself.
Exactly. It feels like it's trying to just hit a big reset button on all the complexity we've built up. Yeah, that seems to be a major goal.
Because, let's be honest, modern physics can feel a bit fragmented, can it?
Oh, definitely. You've got quantum mechanics over here with its probabilities.
Totally different rules than relativity over there, bending space and time.
And then cosmology brings in dark matter, dark energy, things we can't directly see.
Right. It's like different toolkits for different scales.
Motion theory steps in and asks, okay, but what if all of this, all these different phenomena, actually arise from one fundamental principle?
Which is these motion loops.
Which is the structured motion. And this source really hammers home that what we label as mass, time, energy, charge, they're just different manifestations.
Different ways these motion patterns sync up or break down or interact.
Precisely. And the promise, the appeal, is that if you can grasp this core idea, physics becomes, and I love this phrase from the source.
What is it?
Becomes hot, coherent, and weirdly intuitive.
Weirdly intuitive. I like that. It suggests it clicks on some level, even if it's strange at first.
Exactly. That drive for coherence, for a unified picture, is definitely a huge part of its potential appeal. The standard model relies on, 17 fundamental particles, 4 forces?
Something like that, yeah. Lots of moving parts, pardon the pun.
Huh. Right. And motion theory is aiming for something much more elegant, maybe, where all that complexity emerges from this underlying dance.
It's a very attractive proposition, conceptually.
It really is.
And that example of light you mentioned, that really made me stop and think.
The way we perceive it.
Yeah. We're so ingrained with the wave particle idea, but motion theory is saying, no, it's this structured rhythm collapsing into a new sync state.
In changing how we see.
Right. It's not that photons are hitting our retina, but that our eyes are somehow resolving a rhythm, syncing up with it.
That's the concept presented.
Yeah.
And the source uses this thought experiment to make it feel more concrete.
Oh, yeah. Which one?
Imagine a star light years away, and it suddenly just dies, goes out. If light is particles traveling, wouldn't we expect some delay as the last particles finish their journey? You know, travel time?
Logically, yes. You'd think so.
But the argument goes, if we're locked into a rhythmic signal from that star...
Like being tuned into a radio station.
Kind of.
Yeah.
And that signal suddenly stops. The effect here, on our end, would be instantaneous. The rhythm breaks.
No travel time needed because the connection itself is broken.
Exactly. So it forces you to question, well, what is light, fundamentally? How do we actually interact with it? It's a different way of thinking about observation itself.
That is. Yeah, that's pretty radical. And it leads nicely into gravity, doesn't it?
It does, because gravity is another one where the standard explanation feels, well, a bit hard to grasp intuitively.
Totally. The whole bending of space-time thing, I mean, you can sort of visualize it with the bowling ball on a rubber sheet analogy.
Right, the classic analogy.
Mm-hmm.
But space-time itself isn't tangible. You need some pretty advanced math to really work with it.
For sure. So motion theory offers, what was it again? Motion converging.
Right. Gravity is presented as the natural tendency, the natural pull, if you like, of structured motion to converge towards areas of higher synchronization density.
Higher sync density. So it's not an active force reaching out and grabbing things.
Less an active force, more an emergent property of the motion itself. It's not space-time mysteriously curving around mass.
It's just the inherent nature of these motion loops to kind of seek out stability, find these denser rhythmic zones.
That's the picture it paints. And that's why things fall, why planets orbit stars, why whole galaxies hold together. It's all this natural inclination of motion patterns wanting to sync up to find stable configurations.
So insight here. Gravity isn't really a pull. It's more like a natural flow towards the most synchronized beats in this cosmic dance.
Beautifully put, yeah. It shifts the perspective from an active force to a more passive, almost inevitable behavior of the motion itself.
And if you connect that to the bigger picture, does that mean no need for gravitons, those hypothetical gravity particles?
Well, that's one potential implication. If gravity emerges directly from the dynamics of motion, then maybe you don't need a separate force-carrying particle, which, let's remember, hasn't actually been observed.
Right. Still theoretical.
So gravity just becomes a consequence of the fundamental way motion behaves.
Oh, that's a significantly different picture. And the source we looked at, it doesn't just stop at light and gravity. It claims motion theory explains a whole list of things better.
Oh, yeah. The list is pretty extensive.
Like why electrons don't just spiral into atomic nuclei. Why time seems to only flow forwards.
Uh-huh. Basic observations we often take for granted.
Why we see colors.
Mm-hmm.
The whole quantum entanglement thing, that spooky action at a distance.
Yeah.
How that feels instantaneous.
Right. It connects that back to the rhythmic lock idea.
Why light has a speed limit. Even why cosmic redshift might not mean the universe is expanding, which is, wow.
That's a big one, challenging a cornerstone of modern cosmology.
Absolutely. And why atoms are stable, why particles sometimes seem to just vanish in experiments.
Which happens in particle physics, yeah.
The field-like behavior of gravity and electromagnetism, and even EMCO, why mass and energy are interchangeable, but without treating the equation like some kind of magic formula.
Right, deriving it perhaps from the motion principles themselves.
Just quite the claim sheet.
It really is. And what's presented as truly striking is that all these diverse phenomena, from the quantum to the cosmic,
All of them.
are said to stem from that single core principle.
Yeah.
Structured motion syncing up and collapsing or breaking down.
One idea to rule them all, basically.
If the framework holds, yes. It would be a massive simplification, a profound unification. It suggests a much deeper interconnectedness in the universe than our current, somewhat compartmentalized models show.
Okay, but how scientific is this? I mean, it sounds cool, but is it just philosophy, or does it have legs?
Well, the source makes a pretty strong case for its scientific footing, or at least it presents it that way.
How so?
It emphasizes that the theory is supposedly built on logic, on testable predictions, and on observable patterns in nature.
Okay, testable is key.
Absolutely. And it took direct aim at some of the more, let's say, elusive aspects of current physics.
Like what?
like those hypothetical force-carrying particles we haven't definitively pinned down, abstract fields that permeate space, constants that seem arbitrary.
Like, why is the speed of light that speed?
Exactly. Or the idea empty space itself doing these elaborate acrobatics to explain gravity.
The space-time bending again.
Right. Motion theory, according to this source, tries to avoid all that.
How? By focusing just on the motion.
Yes. The emphasis is on simplicity and a direct connection to observable reality. It really boils down to what's moving and what is the motion doing.
Stripping away the layers of abstraction.
That seems to be the goal. Trying to get back to basics in a way, which, raises an interesting question itself.
Yeah.
Where is that sweet spot between mathematical elegance, which our current theories definitely have, and our perhaps more intuitive grasp of the physical world?
That's a good point. So, okay, if this theory is presented as being so compelling, explaining so much, built on logic, why isn't it everywhere? Why aren't we learning this in school?
The million-dollar question.
Right.
The source points pretty directly at, inertia. Scientific inertia.
Inertia in the community, like resistance to change.
Zach, think about it. You have decades, nearly a century or more for some concepts, of research.
Yeah.
Entire careers built on the paradigm of particles, forces, fields.
Yeah, the whole edifice of modern physics.
It's a monumental undertaking to consider that maybe the fundamental labels we're using are not quite right. Everything could actually boil down to these motion loops. It requires rethinking almost everything.
That's a huge ask.
It's a very real aspect of how science progresses, or sometimes doesn't progress quickly. Established frameworks, especially successful ones, have a lot of weight.
Understandable.
However, the source also suggests something else is happening now.
What's that?
That the growing number of anomalies, the inconsistencies, the unanswered questions within current physics.
Like dark energy or reconciling gravity and quantum mechanics.
Precisely. These issues might be creating an opening, a crack in the dam, maybe. A greater willingness, perhaps, to seriously entertain alternative explanations, like motion theory.
So the problems in the current model could be paving the way for something new.
That's the argument presented, that motion theory offers potentially cleaner, faster, maybe contradiction-free explanations for those very sticking points.
It paints a picture of a paradigm shift, maybe just waiting in the wings.
That's certainly the vibe the source gives off, yeah.
Okay. And wrapping up, the source talks about the appeal. It even uses the word sexiness.
Oh, yes, it does. The sexiness of motion theory.
What makes it sexy, according to them?
Well, a few things. It's boldness, for one. It's not tweaking the edges, it's proposing a whole new foundation.
Go big or go home.
Pretty much. Then there's the unification aspect we talked about, bringing everything under one conceptual umbrella.
That's always appealing in science. The elegance of simplicity.
Definitely. And finally, that weird intuition factor again, that sense that despite its strangeness, it might just feel right on some fundamental level.
That seductively simple idea, as the source put it, one coherent principle explaining, well, everything.
It's undeniably powerful as an idea. Whether it holds up to scrutiny is the big question, of course.
Of course. So we really do circle back to where we started this whole deep dive, don't we?
Seems so.
What if everything is motion? And we've just been looking at it the wrong way all this time, focused on the things instead of the dance. We've only really scratched the surface here today, exploring the core ideas of motion theory as this material presents them, and some of its really provocative claims.
And it does leave you thinking, which brings up maybe one final point for you, the listener, to consider.
Yeah.
Think about your own experience, just day-to-day life. How many things are fundamentally rhythmic?
Oh, wow. Breathing, heartbeat.
Seasons, day and night, sleep cycles, music, obviously.
Yeah, rhythm is everywhere.
So the question is, could this deep inherent rhythmicity we experience be more than just coincidence? Could it be a hint that this rhythmic view of the universe, this motion theory idea, touches on something, well, even more profound about reality than we've discussed?
Is the rhythm in us because the universe is rhythm?
Perhaps.
Well.
Something to ponder anyway. Maybe there's much more to explore within this rhythmic view of the cosmos.